Hello, I'm Craig Otto. Today I'm going to talk about the tool called standardized work. It's actually much more complicated and there's several different parts to it than what I'm going to go through, but I'm just going to go through the basics for now. And first of all, in order for you to use standardized work, there's a couple of prereqs. It's 5S, where we get things in order and organized and cleaned. That's sort of a understanding that that's done before you start to standardize. And then, when you talk about a standardized work, what that means is it's the one best way. You don't want people doing something different ways every time because that creates a lot of inconsistency. It can create quality issues and so forth. So, what you do is you basically, a lot of times, the best way to do it is a team of people that is familiar with the process that identifies the one best way through consensus. Not a majority thing, but through consensus, meaning they work through it together and all agree that this is the one best way. That's the definition of standard work. Standard work, it can be represented many different ways. A lot of times you'll see it with the layout of the area, kind of showing where the material flows, how the people work through that process, where the inventory is. And a lot of times they'll also point out the key quality issues and safety checkpoints. Um, basically, the other thing is they'll, depending on if there's machines and different things involved, they also use different tools of standard work to kind of show the most effective combination of the manpower and the machine and so forth. It kind of gets into SMED and some other things, but that's all part of it. Um, the other thing to remember is that the most effective way is the way it is until it's improved, until the standard's improved. Because you got to remember, we're always looking to make things better. So, just because one thing is standard today doesn't mean that it will be tomorrow. And that's why it's very important to keep these standard work documents a living document and to make sure people check it every day because it is a living document. Standard work combination sheets, those just show the steps that a person does and all the associated, walking, manual movement, waiting, automatic times, which would be like for machines and things. So there's a lot to standard work, as you can see. I mentioned earlier the prereqs to standard work. Basically, what you're trying to do is kind of reduce the line stoppages and slowdowns by producing a consistent line of work. You're trying to reduce quality issues, um, but also you need to make sure that the quality parts coming in don't have any issues either, because that's going to stop your line. And it's going to inhibit that standard work from being enacted out. Problems with the machinery, jigs, or tools, again, all of this creates problems when you start talking about implementing standard work, because if something's different every time, obviously you can't standardize it. Part shortages, again, that's going to throw a wrench into things if you don't have your parts where you need them. Um, if you're waiting for a part to work or to actually physically work on, obviously then what do you do during that time? All of these things are kind of like prerequisites that need to be addressed before you start standardizing work. Now, everything, you're going to have these things occur. Kind of what I'm more talking about is trying to address the major issues, because you're always going to have something that pops up that kind of throws a wrench into standardized work. But in general, you want to do quite a bit of problem solving first before you get into standardizing it. The benefits of doing this, basically you're documenting a process that all shifts can use and use consistently. And because of that, you're reducing variability, and basically your process will become much more stable. You know when your job starts and when it ends. It's very clear according to your standard work. It's a lot easier when you're training because you can show the new operator their work scope and what it entails. It should help you be safer in your job. Um, Also, when you do make changes and improvements, it kind of baselines those improvement activities. so that they can be shared and then replicated. It adds discipline to the culture, which is also important. And then lastly, the organizational learning tools, like that supports the audits, promotes problem solving, and involves employees in the airproofing. All of those things are benefits of standard work. Okay, the three parts to standard work is tack time, work sequence, and inventory. Tack time basically is the rate of the customer demand. So in other words, if your tack time is 1 hour, that means you got to produce a part every 1 hour. If your tack time is 30 seconds, every 30 seconds you have to produce a part. Okay. Sequence is the best way to do the process. Again, we talked about repeating that process. That's what standardized work is all about. And then getting into the true lean aspect of it, talking about the standard inventory, knowing how much there should be in each station, in each process, so that it can flow through smoothly. Okay, three parts. This is just one example of a standardized work tool. This is actually called a standardized work combination table. You can see here there's a bunch of line items. Those are the different tasks that the operator will do. It tells you how much time it takes. That's in the manual column. The auto column is the machine. The walking obviously is walking, and then non-value added time. And what you do is just add that time up, and then you do kind of like a Gantt chart here where it shows you the red line represents tack time, and the basically the black lines are the tasks that you have to work on, and the lines with the slashes, they're the slashes with the dots through there. That is basically your machine time, so that the operator can see that as well. So you can see here we've got kind of a process that has more operating time than tack time. So that's going to create a problem down the road because we're not producing to demand. So maybe what you would have to do in this case is actually create two cells that produce the same way in order to achieve that tack time. Here's just another example of another way of doing it, or another tool of standard work is a standard work chart. A lot of times what it's called, it's very similar to the work combination table. The difference being, instead of the Gantt chart, it's kind of like what would be called a spaghetti diagram, where you kind of lay out the process and on how it is on the factory floor, and then you draw in. So basically, one would be where you start, and then you walk to bubble number 2, and then you go to bubble number 3. So it kind of shows you walking all over the process there, and obviously walking is waste. So the goal is to set this cell up maybe differently, and maybe like a U-shaped cell where it flows around. That would be an example of how you use this tool. So this would kind of be like a current state, and then you could improve the process and redo it, showing the new process on the new standard work chart. So just a couple of examples of standard work. Again, standard work is a lot of different things. There's actually 6 different tools that you can use. I just showed you 2 of them. But the 3 main components, again, are work sequence, tack time, and inventory. Just making sure that that's all documented. And really what we're trying to do here is just maintain a good process that we have. And then when we improve upon it, we can standardize it so that we're always doing it that best one way.